Welcome back to the deep dive. Today, we're peering deep, and I mean really deep, into the architecture of modern reliability.
We are. We're looking at a specialized piece of hardware.
It's a silent bodyguard for critical power systems,
hmm
the NTI E-S60VDC DC voltage detector converter monitor.
It is a mouthful.
Okay.
But our mission today is pretty simple, actually.
All right.
We want to show you why looking at this one very specific monitor helps you understand the invisible systems that protect everything. Your phone network, data centers, you name it.
So its main job is just watching power.
Power stability monitoring, exactly. It watches DC voltage sources, so think massive battery banks, telecom infrastructure, all those critical backup systems.
Let's unpack that because we're talking about DC voltage. The specs show it handles both positive, so 0 to plus 60 VDC, and negative voltages.
That's right.
Why do you need that flexibility, that negative range? If it's mostly for new battery backups, isn't that a little bit of over-engineering?
You'd think so, but not at all. That flexibility is absolutely required. A lot of telecommunications and, legacy infrastructure still use negative DC voltages as their standard. So this one device can be deployed pretty much anywhere.
Okay, that makes sense.
And this is where the specs really start to matter for you, the learner, the precision.
Right, let's talk about that precision, because this feels like where you separate the consumer-grade stuff from real industrial protection.
It is. The stated accuracy is tight. We're talking plus or minus 100 millivolts.
100 millivolts.
Plus or minus 1% of the actual reading.
Wow.
When you're managing mission-critical batteries, a 1% drift is often that early warning you need to prevent a total failure.
So it's not just an on-off switch, it's measuring the health of the power supply.
Within razor-thin tolerances, yes.
So we've got this highly precise sensor, the ES60VDC. It connects with a standard screw terminal. But how does that information, that precise reading, get back to the central brain? It can't be a standalone unit.
No, it isn't. It's an extension of the larger NTI systems.
The NVROM-UX units.
Exactly. The E16D, the LANIC 5D, those. And the way it connects is, I think, fascinating because the solution is so low-tech. It's just standard CT5 or CT6 cable.
Wait a minute. Are you telling me that a multi-million-dollar data center's protection is relying on the same cable I use for my home router?
That's what I'm telling you.
How does that cheap cable maintain that kind of precision over, any significant distance?
It's just really smart engineering. The device itself is very low power. It only draws about 30 milliamps at 12 volts, and it gets that power right from the main system.
Ah, so it's powered over the cable.
Right, and that allows it to be placed up to 1,000 feet away. That's 305 meters.
1,000 feet.
All while using that inexpensive cable. The moment it's connected, the central system knows about any voltage drift, long before anything fails.
So you have 1,000 feet of standard networking cable that's acting like a stable electronic nerve back to the hub. That's impressive. But the range can get even more extreme, can it?
Oh, it can. If you need to monitor something really far away, like a utility substation or maybe a long pipeline,
Okay.
the ES60VDC works with the EFSC fiber converter.
And that pushes the distance out to what?
Significantly, up to 1.2 miles. That's 2 kilometers away from the main unit.
1.2 miles. That's vigilance across basically a small city center.
It is.
And it's built to take some punishment, too. The operating temp is, 32 up to 158 degrees Fahrenheit?
Right. So it's not just for those perfectly air-conditioned data centers.
Yeah.
It's built for industrial closets, generator shelters, places where the temperature can really spike. And of course, it meets all the regulatory standards you'd expect.
Like CE and RoHS.
Yes, for international use, and maybe most importantly, it's TAA compliant.
Which means it's approved for U.S. government contract.
Exactly. It meets the trade agreements required for federal infrastructure purchasing.
So to sum it up, this little niche component is really a dedicated long-distance sentinel for power. An invisible security net.
It is. And that raises an important question for you to think about. Given that this kind of system uses common networking cable to detect these tiny electrical changes from up to 1.2 miles away, what hidden vulnerabilities might exist out there in infrastructure where critical power sources aren't being watched with this kind of remote vigilance? Think about all the essential things that fail silently, kilometers away from the nearest person.